The rotate geometry of the third generation system. The X-ray tube is mounted and the detector is mounted on opposite sides, so they are facing each other, and then they maintain fixed opposition as the gantry rotates continuously around the patient. This is the patient at the ISO center. So the detector and the X-ray tube are rotating, okay, taking the information at the same time continuously. So this is very important. The commonly 0.25 to 0.5 per second, they rotate mostly revolution per second. Able 0.25 to 0.5 second, that will be one revolution, one complete rotation. This technology is enabled by what we call sleep ring technology. This sleep ring is very important. It is the main thing that transforms the previous, the most older system of cable, which is taking information, going back for some to and fro motion into complete continuous 360-degree rotation. This is called sleep rings technology, which is going to have high output X-ray tube mounted and the detector on the opposite side rotating simultaneously continuously without stopping. Happening at the X-ray tube. Only 1% of that kinetic energy is going to be converted into X-ray. And out of that 1%, 20 of it is going to 70, no, in CT up to 160 kilovoltage. So very high energy. Whereas mostly the MA, that the current, the tube current, mostly is controlling the current from head of the patient, from head to the toe of the patient. Thus now looking the anode at that tungsten uranium focal tract, because of rotation, as it rotates, that heat is going to be dissipated over a larger area of the focal tract. Remember, this outside area, this peripheral part, is being blackened to enable or to help the heat dissipation and also heat transfer, because we want to get the heat out of the machine. Three methods most important, mostly radiation is the dominant method. After radiation, we got convection. Radiation is the dominant method. Then we have conduction along the stem, okay, out from the stem outside with conduction. We have convection through the oil of the case. Within this, we got oil cover and others inside the vacuum. Outside the vacuum, we have the tube. Okay, the stator is outside and the rotor mostly is inside within the tube itself, within the vacuum. So just part of example. So the rotor lies inside the vacuum envelope while the stator lies outside the vacuum. Photon, the total number of the photons is going to go down. So filtration decrease quantity